Hello students, today we are going to solve numerical of Webster's method. Question is given as the average normal flow of traffic on crossroads A and B during period are 400 and 250 passenger car unit per hour. The saturation flow values are 1250 and 1000 passenger car unit per hour respectively. The all red time required for pedestrian crossing is 12 seconds. Design two-phase traffic signal by Webster's method. Now in the question, QA is given as 400 passenger car unit per hour. Similarly, QB is given as 250 passenger car unit per hour. Similarly, SA will be equals to 1250 passenger car unit per hour. Similarly, SB will be equals to 1000 passenger car unit per hour. Now we need to determine the value of YA, which will be equals to QA upon SA. By putting the value of QA as 400 and SA as 1250, we will have the value of YA, which will be equals to 0.32. Similarly, we can determine the value of YB, which will be the ratio of QB upon SB. By putting the value of QB equals to 250 and SB value is 1000, it will be equals to 0.25. Now we need to determine the value of Y, which will be equals to YA plus YB. On putting the value of YA as 0.32 and YB as 0.25, we will get the value of Y equals to 0.57. Now we have the value of all red time equals to 12 seconds. So we can determine the value of L equals to 2n plus R. Here the value of n is 2, so it will be equals to 2 into 2 plus 12. By adding this, we will have the value of L equals to 16 seconds. Now C0 will be equals to 1.5 L plus 5 upon 1 minus Y. Now after putting the value of L equals to 16 seconds plus 5 upon 1 minus 0.57, it will be equals to 67.44, which is nearly equals to 68 seconds. So C0 will be equals to 68 seconds. Now we can determine the value of G dash A, which will be the ratio of YA upon Y into C0 minus L. On putting the value of YA as 0.32 and Y as 0.57, the value of C0 is given as 68 and the value of L is already determined, that is 16. On solving this, we will have the value of G dash A equals to 29.19, which will be nearly equals to 30 seconds. Similarly, we can determine the value of G dash B, which will be equals to 0.25 divided by 0.57 in bracket 68 minus 16. On solving this, we will have the value of 22.80, which is nearly equals to 23 seconds. That is the value of G dash B. Now we can determine the value of G dash, that is effective green time equals to green time plus amber time minus total lost time. Here total lost time will be equals to all red time divided by 2, it will be equals to 8 seconds, that is the average value of total lost time. So we can determine the value of G plus A, which will be equals to effective green time of A minus, similarly we can determine the value of G plus A, which will be equals to effective green time of A plus total lost time. So it will be equals to 30 plus 8, that is 38 seconds. So green time plus amber time will be equals to 38 seconds. Now green time for B road plus amber time of B road will be equals to effective green time of road B plus total lost time. It will be equals to 23 plus 8, which will be equals to 31 seconds. So, green time of road A plus amber time of road A will be equals to 38 seconds, and green time for road B plus amber time for road B will be equals to 31 seconds. That is all about this numerical. Thank you very much, students.